Hi everyone, I'm Vivek Singh and I'm excited to present my project AI powered waste classification. So let's look at the problem statement and the objective of the project. So the problem statement is improper segregation of biodegradable and non-biodegradable waste causes pollution, increases in landfill load and complicates recycling. So basically, it's we are trying to solve the problem of segregation or classification of biodegradable and non-biodegradable uh, waste by automating the process. So the objective of the project is building a lightweight, accurate classifier that runs on edge devices to automatically classify waste from camera input and assist smart bins and low power devices. So this is the data set overview. So basically, I have taken 45,000 images for training plus validation plus testing. And for testing, I have used 5,017 images for the final evaluation. There are total two classes, biodegradable and non-biodegradable. So in biodegradable, there are 2,794 images, and in non-biodegradable, there is 2,223 images. So, and these are some of the pre-processing steps, like resizing the images to 128 cross 128 dimension size and channeling the order of color format to RGB. I have also augmented the images by randomly rotating the original image data set, and this is the model architecture of the image. So basically, we are taking the image from edge camera, and we are pre-processing the image, and uh, and then it is uh, passed to the efficient net B0 model, and then it is converted to the uh, TensorFlow Lite format in 8 model. And these are some of the model and training details. So the base model is efficient net B0 model, and input shape is the 128 cross 128, and RGB color format is RGB. Classes, there are two classes, biodegradable and non-biodegradable. The framework which is used for the project is TensorFlow plus Keras, and architecture is efficient net B0. And there are total four layers after this. So the first layer is global average cooling. The second is dropout layer. Third is dense, and there are two dense layers. So the first two is uh, for prevent the model from overfitting, and the last two are for binary classification. So there is a total the data set size is 45,000, and optimizer is Adam, and epochs is total 25, and batch size is 32. And augmentation, I have taken rotation. So and the loss is categorical loss entropy, and matrix for evaluation is accuracy and F1 score. So the results of this model was accuracy achieved is 93.12%. F1 score is 93.15, and inference is 0.07 seconds. Model size is 16 MB for float, and for input it's 4 MB. So this is like quantization and edge deployment nodes. So basically for low powered MCU devices, Int8 model is preferred because it requires less RAM and ROM for operating on this type of devices. And for other devices, we can use a float model. Uh, so there is like we can see the performance and metrics for test set. So for the test set, the float model is giving the accuracy of 93.12%, and F1 model is giving accuracy of 93.15, and average inference time is 0.071 second. And when we are normalizing it to 0 to 1, its accuracy is decreasing to 44.31, and its F1 score is reducing to 27.21. And this is the confusion matrix of the project. So 2,518 images are classified correctly into biodegradable, and 276 is wrongly classified, and in non-biodegradable 46 is wrongly classified, and 2,177 is correctly classified. So these are some of the submission and artifacts which I have submitted for the final hackathon. So the first is the a float model. Then I have also submitted Int8 model and the .h5 Keras model. So this is a deployment architecture. So The camera will take the image and it will be pre-processed. Then it will be uh, on device TF light inference. It will be there, and then it will be then it will be predicted on the TF light model, and then it will be sent to the cloud for analytics, and then the final action will be taken on the smart bin action or this dashboard. So let's look at the live demo of the project. We have to give access to the camera for this project. So let's try to predict some biodegradable as well as non-biodegradable objects. So yeah, it's classifying this apple as an biodegradable, which is correct. Now let's take this tomato, and it's again classifying it as biodegradable, which is exactly correct. Let's try on some other things like lemon. It's again classifying it on biodegradable, which is exactly correct. Now let's try this coconut. Now again, this is correct classification. Let's try on this some vegetable. Exactly, I don't know the name of this group. So again, it's classifying it and classifying it as biodegradable, which is correct. Now let's try. Let's put this ginger. Now again, it's correct. Now let's try some non-biodegradable objects like this spectacle case. It's non-biodegradable. Well, let's try with this pen. Non-biodegradable. Now let's try with the phone. It's non-biodegradable. So that's it for the project, and yeah, I think I hope you like the project. Uh, Thank you.